Welcome to our webinar today. We're going to get started in a couple of minutes. I did want to just get everybody oriented. In the question panel, you'll see the ability to ask questions. So please put your questions in the question panel as you go along. We will also be sharing all of the slides and the webinar recording with everyone that is actually listening. So please participate as we go along. We'd like to have it to be a dialogue, not just a one-way discussion. So my name is Lora Cecere. Today we're going to talk about improving demand and the selection of demand management tools. You know, people, when I go around the world and talk, say, Laura, who are you? And I'm a social scientist. I'm a little bit as goofy as this picture. I do research, and I'll share some of the research today, and I help business leaders to think of the questions that I think they should ask. Whereas the consultants will basically tell people what they should buy and solutions that they should select. What I try to do is use research as a vehicle to help people to think about the questions that they should ask. And unlike other analyst groups that write for IT, I write for the supply chain business leader. So I write for Forbes, I write for the Supply Chain Shaman blog, I write on LinkedIn, and my goal is to really help supply chain business leaders. Today we're going to talk about demand management, selection of technologies, and how these technologies are evolving. And to put us in the right mindset, I want us to think about demand as a river. Demand is a river that starts with the tributaries of our customers, flows through our customers' distribution channels, through our distributors to the organization. And as we think about that flow of demand planning is essentially a snapshot of time phase demand that people will capture in the river. And different industries will capture the snapshot at different points. So what happens in consumer electronics, the snapshot is taken to convert finished goods to sourcing supply. In the case of consumer packaged goods, the snapshot is taken to look at order signals to be able to maximize customer service and distribution requirements planning. In retail, the snapshot is taken between the distribution centers and the stores to help the retailer get the right product to the shelf. So demand is like a river. Where we choose to take the snapshot for forecasting really is based upon the goal, and the frequency in which we do that is based upon the velocity of the river. Now, the data that we use should be reflected on the goal, and we cannot lose fact, despite the fact that we are working with time series data, the demand is a river. And what I help clients to do is to really imagine the river. And so this was a consumer food and beverage company. They basically make pet food. They had tributaries that started with their local retailers. They navigated the river of demand through their tributaries, looked at how could they use the river of demand, and they looked at what the rocks were in the river. Now, most people don't think about demand as a river. In fact, I teach a boot camp, and one of the first exercises I do is I ask people to draw the supply chain, and they look at me kind of crazy, like, draw the supply chain, really? And 99% of the people who draw the supply chain will draw something like this. It starts with supply, transportation, and then at the very end, they'll have a customer. And I argue that the best supply chains start with the customer. They start with the customer's customer. They translate demand as a river through the supply chain. And the focus is on the customer, not as a focus on supply. We basically translate the demand flows into supply. However, today, based upon our research, and we sit on 9,000 responses, current success is like a flip of a coin. 50% of people are satisfied with their current demand management solutions, which I define demand management as forecasting plus demand sensing along with business analytics to use the data. And they are not as satisfied in emerging economies of South America, Central America, Middle East, and Asia, where our usability of data is lower, and I think people are not as attuned to the concepts of the river of demand. And in those areas, the data tends to be less predictable for patterns. So to be able to navigate the river of demand, we've got to learn to speak the language of demand. We've got to really fight against the hardwired tendency of thinking about supply. And so the language of demand, as we think about the language of demand, we must start with demand sensing. And demand sensing is the reduction of demand latency to sense purchase and channel takeaway. And channel takeaway looks at what is actually happening at the moment of truth when that end consumer or customer buys the product. Reduces demand latency, and we'll talk about demand latency. And demand latency is the time it takes for the purchase at the channel to translate to an order. And one of the issues in demand management is demand latency has increased 3 times. So it's 3 times longer than when I was a supply chain professional in regional supply chains. So when we think about the translation of demand from that end use point to an order, that time represents demand latency. And I work with some companies where demand latency is 120 days. So they're looking at forecasting based upon order patterns, and they have a lot of demand latency. We also must think about the type of demand. So independent demand, the purchase of a product by a customer, and dependent demand is the translation of this demand signal for manufacturing or bill of materials or transportation. And the translation of independent to dependent demand is what advanced planning is all about. But we must really look at independent demand first, and we must look at how clearly are we translating independent demand to dependent demand and hold ourselves accountable for demand error, for bias, for forecast value add, and the real improvement that we're driving through demand processes. Now, demand translation actually translates independent demand into role-based usage across the supply chain. So sales, procurement, manufacturing. DDMRP is a type of demand translation. DDMRP stands for Demand-Driven Material Requirements Planning. It is a type of demand translation for procurement. Demand shaping is the use of demand tactics, price promotion, to really increase baseline lift. Baseline lift says if I don't do anything to the demand signal, this is what people will buy. Many people confuse demand shifting for demand shaping. Demand shifting basically shifts demand from one quarter to another. So demand shaping is best when we have elastic usage. So for example, potato chips or chocolate or wine are elastic in my pantry. If people promote those items, I tend to do more shelf loading, and I will tend to consume more of those items. So demand shaping, where I have elastic demand, is much more effective than demand shifting, where I'm just shifting from one category to another. So these are some terms that we'll talk about as we talk about demand. And often when I have these discussions, people are like, whoa, Laura, we don't use these terms at all. And I'm like, exactly, you're hardwired for supply. And so as you think about the language of demand, we also have to think about forecastability. So how easy is it to forecast? And this is the determination of the probability of demand. And many technologies have this included in the baseline package. And when I work with clients and I ask them, what is the forecastability of your data now versus a decade ago, they'll find that it's tougher, right? That sometimes demand error, and despite what they do, has actually increased twofold. Forecast value add is what is the improvement that I'm adding to the forecast through demand against the naive forecast, which says if I don't do anything else, what did I sell last month? Downstream data is channel data, and demand synchronization allows me to connect the node from node to node. I never want to integrate data. What I want to do in demand is I want to focus on demand visibility through harmonization and synchronization of the data, and really working on consumption of the data across planning horizons. So how have people gotten demand planning wrong? Well, they focused on buying a system, implementing a technology, without really mapping the river of demand, not really saying what is the goal of demand, and not able to look at what is feasible. So how forecastable is the data? How do I measure if I'm improving the demand plan through forecast value add? And how am I able to translate the demand into a demand visibility signal? And because people ask the wrong questions, they're not very happy. So in North America, 50% of companies are satisfied with their demand planning systems. In other regions of the world, it's 30%. And I think it's because we're asking the wrong questions. So I have a question. How do you estimate forecastability? Thank you, Edgar. We backcast. And the way we backcast is we'll take 3 years of history and we'll try to forecast the current year. So we're currently in 2019, so we don't have but 2 months of 2019, but we would have 2018. So we would take 2014, 2015, 2016, and maybe 2017, and we would try to forecast 2018, and we would compare that against actuals. And we would look at, given the best technology in backcasting, what is demand error? And we would look at that across time. So what was the best demand error we could have had in 2016, 2017? And the process of backcasting uses history to forecast a known quantity. I hope that that helps. And so what we need to do is divide that forecastability analysis into high volume, very predictable SKUs, things that are intermittent demand, things that are discontinued demand. Really look at that by demand types as we look at forecastability and look at what are the contributors of demand error and how have the basic product profiles in my demand stream changed. Thank you for the question. If you run John Galt, which is a demand planning system that comes, on the dashboard, which allows you to know what was the baseline forecastability of that particular production run. I know Owen Partners is looking at putting it into their system as well. If it is not in your current demand planning system, you should ask for it to be put in the implementation, which basically says what is the best that you can do with an algorithm based upon the order profiles or the demand data to be able to drive improvement in demand. What is the natural demand error? And when you have demand error, there's not much you can do to improve demand error if that's as good a model as you can get. Sometimes people in supply chains don't want to accept the fact that, new product launch has a 70 to 80% demand error, or that certain products have a 60% demand error, but sometimes that's the best you can get. And when you have high demand error, something greater than 40%, you really want to look at inventory strategies. You want to look at form and function of inventory, push-pull decoupling points, the design of the inventory, the design of the network, the mode to market, and work with that demand error, sort of like dancing with the error around the probability of demand. You never want to try to get precise on imprecise data. Instead, what you want to do is look at the probability of demand and design the supply chain for it. And Mark says, well, should it be called a demand chain? Maybe. I mean, I find supply chain is a very, very political term. It means something very different in every organization. And, you know, in 1980s, I really fought to get a supply chain organization. And I wanted it to be from the customer's customer to the supplier, a broad term. But what many people have implemented is supply chain management as a function, a very narrow function. And so this concept of demand flows and mapping the flows from the customer's customer to supplier is very new for most companies. And it's very different than just plugging CRM or customer relationship management, which is really a sales effectiveness tool, into advanced planning. Instead, it's, you know, an exercise to be able to look at what are the demand flows. Where do I have fast current? Where do I have slow current? Where do I have eddies? And if you want to call it a demand chain instead of a supply chain, maybe that will work for you. But, you know, I find that the term supply chain is pretty heavily burdened anyway with a lot of nuance. So let's continue. Thank you for the questions. Love having a dialogue. So as we think about management of the supply chain, I just want to give you a perspective so that you think hard about this and the so what, who cares. So you might say, well, Laura, I've got demand error of 60%. Why should I care about demand management? Should I forecast at all? And absolutely you need to forecast. And you need to understand that demand volatility is one of the largest risk factors that we have. So if we look at 5 years ago versus the future 5 years, and we look at risk factors, you can see the size of the demand volatility bubble is bigger, even though it's underneath economic uncertainty, and we certainly have had a lot of that, and supplier viability. We don't give our suppliers good demand signals today, and that is an issue with supplier viability. We've pushed cost and waste back in the supply chain, despite the fact that we talk about collaboration. And demand volatility is really high. And so unless we know what demand volatility is, we can't really design for risk and for inventory strategies. And you can see here that inventory levels post the Great Recession are higher than they were pre-recession, despite the fact that we spent 1.7% of revenue on technology in this space. And this is because people are not taking the demand error and thinking holistically about inventory into form. What form should the inventory be? Should it be a raw material, a semi-finished good, a finished good, or function? How do I improve cycle stock? How do I improve in transit? How do I improve safety stock? Most people only look at safety stock. And how do I manage slow and obsolete? So the translation of demand error needs to go into form and function of inventory. If I have very high demand error, I will want to keep more products as semi-finished goods, work in process, or raw materials, and deploy push-pull decoupling points and postponement strategies to basically manage demand error. If I do not do that, then I'm going to have high write-offs and I won't be very agile. And so one of the issues that we have is we have put broad brush demand planning tools in, with everybody going to basically look at order profiles translated into safety stock, without really thinking about what drives demand error. What do I do with high volume products? What do I do with intermittent products? What do I do with declining products? And how does that tie to inventory strategies? The other area of opportunity is tying demand error into buying strategies. Now, I'm an old gal. I've been in supply chain management for about 40 years. I've never seen commodity volatility like it is now. Commodity pressures, both availability and cost, are very high. And few companies have the ability to translate demand into aggregate buying strategies. And so this work to translate this into commodity buying strategies and to manage inventory and to dance with the river demand to improve customer service, I think drives the manifesto for change. So when we look at today's reality, in certain industries, we've got a lot of complexity. In fact, one of the questions I just got is, isn't item complexity one of the factors? And absolutely, item complexity introduces the long tail. Excuse me, we're going to talk about the long tail, but this is today's reality in consumer goods. This is a shelf at a very small store. It's a drugstore, and it's in an area of toothpaste, which has become very complex, a lot of items. And you'll notice to try to grow this brand, this company has introduced a new product at a discount. So they're trying to shape demand, although I would argue that they're shifting demand. And look, they've paid a lot of money for an empty shelf. Well, the demand latency or order latency for this particular product, because it's a new product launch, is probably 3 months. So they'll never see the need for replenishment of the shelf in a reasonable order cycle. Instead, what they need to do is use customer data, outside-in data, could be images from robots in the aisle, or look at item complexity rationalization and promotion rationalization to be able to streamline this to shelf, or perhaps look at different strategies to get the product to the shelf. But because demand error is high for this product, and because they're shaping a product that has high demand error without sensing the shelf, they've paid a lot of money for an empty shelf. Now let's go back to 2007. Let's think about, why outside in makes sense. How does it tie to demand planning? So when we think about market forces, and every day I read the Wall Street Journal, and these are some headlines, a lot of commodity volatility. How do we translate demand error to be able to orchestrate demand? So in this case, orange juice prices are higher. Perhaps sourcing strategies should take it out of a hurricane region to another region, but how do I know that if I can't orchestrate demand with a good demand error? Coming out of the recession, in most recessions, cereal increases in consumption. In this particular recession, consumers walked away from both General Mills and Kellogg, and they walked away from big food brands. General Mills, who sat on more consumer data than anyone else in the industry, failed to read that market because they were only looking at orders. They weren't looking at the shelf signals. Ford, similarly, failed to look at the changes of mix of buying of what was happening in the market because they were looking at historic orders. So when we think about inside out processes, we're focused on how do I manage the river of demand based upon orders. When I'm looking outside in, I'm doing a snapshot of what is the market buying. And I think if we have a recession, which I'm concerned that we might because inventory levels are rising. I got a call last week from the Wall Street Journal about that. I see more and more chemical companies putting Q1 holds on travel. Often happens as recessions start. I believe that it will take us longer to respond to the shifts of the demand river in the next recession than it did in 2007. 6 months was what it took laggards. 3 months is what it took leaders. And the difference being that leaders looked at market data, not just order data, and the river demand, and they were open to be able to talk about the river demand versus laggards were modeling off of demand orders. So with that, do we have best practices? I think in most companies not. 50% of companies are happy with their demand planning systems. Most people are very supply centric. I think we've got historic practices that we've really got to challenge. And I'm going to give you 5 pitfalls that I think might help. The first pitfall is the evolution of the long tail. As we think about the long tail, the area in blue is the normal distribution. It is the high volume, very predictable demand. What you'll see in this area is demand error under 33%, mean absolute percent error. Anything but normal is the long tail, where we start to get a skewed distribution. So when you think back to statistics class, a normal distribution is a bell curve. A skewed distribution will be skewed around the median. And as we think about moving to a skewed distribution, the traditional techniques for forecasting don't work as well. And also the error in the long tail can have big impacts if we don't recognize the nature of the river for the long tail versus the river for high volume products. And the long tail demand tends to be very intermittent, very unpredictable. We will never manage replenishment by just pumping, a finished good into DRP. Instead of what we need to look at is postponement strategies, late stage differentiation, product simplification, and perhaps make to order for the long tail. We will never get good at forecasting the items on the long tail. And we need to think about complexity as it ties to demand error. So one question is, how much demand error is acceptable, and how do you align inventory through the system? That's Sandra, and thank you, Sandra. Good to see you. Demand errors and how much is acceptable is sort of like how big is a man's legs? How tall is a man, right? They come in all different sizes. Demand error, the median in consumer products is 33%. Some people are down into 20%. But on the long tail, demand error can be 60 to 70%. In consumer electronics, you'll see demand error to be 60%, 70%. And that's error. And so, we got to design the supply chain to use the error. And the error gets into inventory strategies and what to do with that error. So as you think about this consistent and forecastable demand, this particular client had 874 items representing 77% of the volume and 74% of net sales. And they had inconsistent demand on the long tail of 1,700 items representing 23% of the volume, 26% of the net sales. Now, one answer might be, well, just cut the items in the long tail. Maybe you can do that. But a second answer is, should we think about how we manage the modeling of the long tail, knowing that it is a skewed distribution? And should we rethink the inventory strategies for the long tail, knowing that it's not forecastable by conventional means, looking at form and function of inventory, postponement, decoupling points, and really recognize the river of demand and the fact that the higher the demand error, the greater the bullwhip effect, the greater the amplification. So if I treat the long tail in a standardized method, I'm going to really distort demand. So the first is, in that river of demand, let's recognize the long tail. The second issue is that most companies have big gaps in alignment. They think, well, let me ask sales what they're going to sell, and perhaps that should be a good representation of the market. If you sit 5 functions around the table and you ask sales, marketing, finance, manufacturing, procurement to forecast, the highest error and bias will come from sales because they're naturally coin operated based upon bonuses. Whereas marketing and operations also have big gaps in terms of how they see demand. Operations will typically be taking a time phase snapshot on orders, whereas marketing will be looking outside in on market data. So closing the gap with the organization can help by mapping the river of demand and helping people to say, I'm getting a snapshot of demand through that river. Now, we have to manage demand like a decathlete, and one of the things we have to do is manage cost. And when we think about that river of demand and we translate demand into each function, we've got to look at how do we manage total costs, not just transportation costs or procurement costs or manufacturing costs. Because sometimes satisfying customer service on intermittent demand means that I've got to increase transportation costs. So maybe I've got to ship more frequently or ship in smaller trucks or make smaller batch runs in manufacturing. And the focus needs to be on total costs, because if not, I will never align for what's happening in the demand signal. The third pitfall is measurement. And the efficient supply chain, or the lowest cost per unit, is usually not effective, particularly if we're dealing with demand error. And so we should look at what is the demand latency, how long does it take me to read markets, what is the forecastability, what is the forecast value add, and how does that tie to the balance of growth, operating margin, inventory turns, and return on invested capital. Now, I have a question for a commodity like cement, where demand is cyclical, regional, based upon many external factors. What would you suggest as a demand planning solution? Good question. I don't know how big you are, how many demand planners you have. What you've got to do is look at what can model demand. And that gets me to modeling and getting access to the data to make decisions. One of the things you don't want to do is depend heavily on Excel spreadsheets. 68% of the market is very dependent on Excel spreadsheets, and they're isolated and disconnected. Instead, what you want to do is you want to look at your inputs of what is the data that you can model, what is the best engine to drive the modeling, to drive a demand plan. And then look at planning master data, things like item definition or lead times. And understand that planning master data is usually not a constant number, but a range. And test the solution to be able to look at demand planning in that river that looks at tactical planning and translates it to demand sensing for replenishment. Our river has strategic implications, which get to how we design the supply chain, tactical, and basically demand sensing. So let's get to selection. Most people have very complex environments. They've got 12 ERP instances. They've got 5 to 7 APS systems. And when they look at the criteria for selection of a demand planning tool, they're not clear on what matters. And in fact, I often have companies that will basically go into the market and they'll look at demand solutions, and maybe they'll be 7 to 9 months in the selection of demand tool. And they'll call me up and they'll say, what tool can I use? What will be the best tool? And I'm like, why are you asking me? Your first thing that you should do is model the math, backcast. Take 2 to 3 years of history, try to backcast and model for 2018. Then you need to test scalability. How many users do you have? What's the scalability of the data? What user interface do people prefer? What's needed for collaboration and what-if analysis? Only a third of companies have what-if analysis. What are your requirements for systems in your organization? What is your culture? What is the system of record? And then the last piece to consider is integration. Basically, integration has been used to push the same system with the same label. But most of the time, what you have is many companies have bought a lot of systems and put the label on, right? So JDA bought Manugistics and I2 and slapped the JDA label and marked we're end-to-end solutions, right? Agility bought Option and Halo, again, end-to-end solutions. Most of those solutions have a common name, but they're really not necessarily integrated. But we have to start with the modeling. We have to start with the math. We have to ask ourselves, what system will drive the best answer based upon the characteristics of my demand patterns? What data should I use to drive the best answer? What do I need to do in terms of master data to be able to drive the best answer, to drive the best plan? And how does this tie to the rest of my systems? Now, by asking those holistic questions, I'm going to select a solution based upon the needs, not based upon some false sense of security because I have the same system from the same company. And there are lots of cloud-based, low-cost systems that are in the market today, and it's really great, that, we have a lot of alternatives. When I was working in 3 decades ago, the systems were very costly. They were hard to use. But now there are lots of systems that, are easier to use and allows us to get through this. So start with modeling and math. And the last thing to consider is integration. Now, most companies have made a mistake by focusing on integration first. How long does it take to run tests with the vendors? 4 to 6 weeks. The most time is getting the data. So getting the data is probably the biggest pole in the tent, so to speak. So when considering a modeling engine, shouldn't most be considering one that is stochastic? Well, Bob, it really depends upon the nature of data. I find some companies have very high volume, very predictable, and they don't need a stochastic engine. The type of model is really based upon the data quality. So I can't just say one type of model will fit better. So you've really got to start with the data and test and learn. And remember that Excel is not going to model demand planning. It's just not effective. So when we think about the selection of the tools, we got to go through the requirements process to really answer the question of what's best. Now, I skipped around a little bit. Let me go back. Sometimes companies ask me to come in and look at their planning systems and say, how mature are they with planning systems? And there's a lot of, I think poor research in the market that confuses people. But what you need to have is a clear vision of what your planning systems are. At the top, you've got strategic planning, and the time horizon for strategic planning should be the planning horizon for you to make decisions on strategic purchases, manufacturing, contract manufacturing, asset strategies, new product launch. And that is usually a small group of people that are doing modeling around where should I have assets, what should I outsource, what countries should I go in, what are the implications. And then sales and operations planning is usually a system that overlays the 5 to 7 APS systems, connects sourcing with suppliers, and looks at how do I balance demand and supply to optimize profitability, maximize value, and minimize risk. Forecasting on the demand side is where I'm going to take that time phase snapshot in the river demand to be able to translate across the organizations in the tactical horizon, which is typically 12 to 52 weeks out, can be in weekly or monthly buckets. And demand sensing translates the tactical forecast or that snapshot into daily buckets to be able to be consumed into DRP. DRP is distribution requirements planning. So when you select a demand planning solution, you need to also think about how it fits in to the holistic planning decision support architecture, how you're going to use that demand signal and what this means. And I have never found a company where I go in and I look at the maturity of planning systems, it's all green. Green is better than average, pink is average, and red is below average. I never find a company that's all green. But the ability to forecast and to forecast accurately is one of the most important elements of planning. And despite the fact that you may have high demand error, you need to be able to translate that error into action. So today we have an input for shipments and orders. We do the data model. We push out a time phase forecast. In the future, we are using machine learning for market data, for the input data, cognitive computing and ontologies, and schema and read for the evolution of demand data. And we will be driving continuous sensing and learning acting engines based upon the shifts that we're seeing in demand. And as you think about, the evolution to be able to look at machine learning and continuous improvement and cognitive computing, don't just try to go there today. That's really for the early adopters and the innovators, about 3% of the market. What you should start with is the modeling, backcast, forecast value add, error. Hold yourself accountable for what value is your demand planning process bringing to market. And when we would distribute these slides and we distribute the call, I'll send you the methodology for forecast value add and forecast stability so you can get into your own math and start to map your own river of demand. And when people talk to you about integration, just kind of laugh and talk to them about modeling, and the best use cases are able to give you great data on the river of demand. Now, I try to provide actionable insights for people around the world, and I write in front of the firewall, and I share these webinars monthly, and my goal is to drive a guiding coalition, and every year I do an annual conference, and I'm really trying to stimulate that we can drive improvement because 90% of companies are stuck. They're just not driving improvement. And most people, when I go talk to them, just really shake their head when they talk about demand. So I want to talk about a couple of case studies that thought about the river of demand differently. The first case study is a case study of an allergy company that had a demand latency, order latency, of 120 days. So the order appeared for the manufacturer 120 days past the time that the people bought the pills on the shelf. Needed to be a very responsive supply chain because sinus allergy type products are driven by allergens in the air. And what they were doing is they were mapping all of the order data and all the downstream data together, and they could not see regional differences. And so they were always out of stock. So what they did was they mapped the river of demand from the customer's customer, the supplier's supplier, and they looked at what were the triggers by each region to be able to look at what was going to be required. And they found that their modeling was best served by using a combination of channel data, so what was happening in the store along with retail replenishment, and to be able to model the allergens, so the smog index by zip code or the pine pollen index or the oak trees. They had 6 to 7 major allergens that they started mapping. And as they thought about the river of demand, what they started to say was, let me look at microsegmentation, which we can currently use in, a lot of our data-driven concepts with, schema and read. Let me look at how I serve markets differently based upon the drivers. And by doing this, they grew their market 5%. And they had a lot less slow and obsolete by looking at market drivers, not just looking at orders and not being supply centric, but to be outside in based upon the demand signals. The second case study I want to give you is unstructured data and listening. A lot of times people will say, Laura, I just can't model new product launch. Demand error is high. And yes, it is 70 to 80% error. And I don't know what to do with new product launch. And so I recommend people build listening posts, and they basically listen to unstructured data of all forms. Maybe it's return data. Maybe it's warranty data. Maybe it's customer sentiment data, rating and review data. But this is a case study of Lenovo. And Lenovo had an issue with they couldn't read the success of new products. So they started taking rating and review data, and they started listening to sentiment. So this is for the yoga product. So you can see yoga. And they're looking for issues that consumers might have, and where consumers have significant issues, they realize that perhaps the market is giving them feedback around acceptance. So they can look at customer acceptance and success of the product in the field really quickly versus reading this market, which can take 120 to 180 days. So they would basically listen together weekly, and then they would look at the demand data and the what-if analysis, and they would trigger it. So if they're seeing a lot of negative sentiment for one of their products, they would tamper back on a particular item. So when you think about demand and you think about demand modeling, we should really model with the goal in mind. Looking at the river, thinking about what models. So this particular client, this where I started, found that they had implemented a very good demand planning technology, and they had basically degraded the forecast by 33%. 14% was because of the technology, and the remaining was because of process and skill level. Now you might say, well, how can a company use a good forecasting tool and degrade the forecast by 14%? Well, it's because they didn't model to test if it was a good tool when they selected it, and they never held themselves accountable for forecast value add in the implementation to say what value was the company driving for the demand process. So you can see up here in the corner, they weren't sure of the true north. So the first thing you need to do is get really clear on what good looks like. Measure yourself by forecastability, error, bias, and I prefer mean absolute percent error over weighted MAPE. Second thing is look at the tributaries. What data is in your tributaries? And should you model these tributaries as a central river, or should you be modeling each of the tributaries to be able to look at what's happening in markets? Remember, the Sinus company decided to model the tributaries based upon regions. What drives demand? And then where in this river should you take your time phase snapshot for tactical demand? And how do you translate it into inventory? And this particular company had 8% of their volume that was never forecasted because they had all these marketing programs that were kind of one-off spreadsheets that sort of surprised them. So you need to be sure that you forecast all your demand. Make sure you can model it, forecast all demand, try to get rid of your Excel spreadsheets, make sure it's usable, think about demand as a river. Now, when we think about tools, we can't forget about people, and let's just kind of look at this, right? You know, a lot of times demand planners sit in cubes and they don't feel very loved. And we've got some senior leaders that may be getting ready to retire, and we've got millennials that really wonder, why are our systems so hard? And, you know, when we look at satisfaction, the most satisfied people are vendors and academics. Our end users are the least satisfied, and our millennials are also not very satisfied, and that's because we don't necessarily have systems that fit them very well. So as you think about this whole level of demand, and we need to support the demand planners because it's an area of a lot of turnover and people are not very satisfied. I want you to really start embracing next generation supply chain thinking. Think about the river demand. Try to unwire your brain from supply. Think about the selection of tools. Really work with your employees to develop the skills. And give your demand planner some love. You know, I wrote an article recently on Valentine's Day of have you given your demand planner some love today? They're the most dissatisfied employees in supply chain. Most supply chain demand leaders do not feel that they're well understood in very supply-centric organizations, and they really need love. And makes a difference when they have an executive team that understands demand, they have visibility of the demand signal, and cross-functional alignment and the ability to use data. So don't just buy a solution because you're going to focus on integration. Do the hard work, model, hold yourself accountable for demand error, and in the process, learn to unlearn to relearn. Just because a demand process works well at one company may not work well at yours. Think about inputs, think about modeling, think about outputs, think about your time horizons, and holding yourself accountable. Focus on the basics, measure, forecastability, forecast value add, modeling, clean data, and build the executive understanding. Now, Greg says, Laura, why do I not prefer weighted MAPE? And Greg, the reason is that when I benchmarked 85 companies, I found that when people looked at weighted MAPE, they hid the impact of intermittent demand in the tail, and they had lower customer service. So weighted MAPE basically will give you a false sense of doing well, and the long tail is typically where you have the greatest customer service issues. So that's our webinar for today. If you want to know more, we do have our event that will be happening September 3rd through 6th in Chicago, where we'll imagine the supply chain of 2030. We will be live casting it. I hand select all of the presentations for this event. And so there are no paid speaking, no sponsorship demos. And we also have our demand share group, which meets monthly, and we talk about these concepts. And our next meeting is at Land O'Lakes. We do 3 face-to-face meetings a year, and our next meeting we're going to invite demand planning technology innovators to come and talk, and then we're going to do a visioning session of demand planning 2030. And we also coordinate our Network of Networks group, which looks at how do we translate demand and improve signals across networks. So again, my name is Lora Cecere. I'm trying to help people to build next generation supply chains. We do monthly webinars, monthly networking calls, and it's my hope that all of our research can help you improve your supply chain. Thanks for joining, and all the best. If you have any questions, send them to me, and I look forward to the response. Thank you.